All right, hello everybody. This is chapter 5.2, coming from the Holt McDougall curriculum for algebra. The common core standards that we will be addressing in this lesson are here on the left. And to kind of break that down to specifically what you will be doing is over here on the right. We are going to be solving an inequality using multiplication and division. Okay, we are expanding our knowledge of solving to inequalities. And the great thing here is it's almost exactly the same. There's just one slight little difference. So if you could solve an equation, you can solve an inequality. Let's get started. First up, there we go. We're going to solve an equation using multiplication. And remember what we talked about in our section 5.1 videos. Solving, we kind of follow three things. The overall goal is to isolate the variable. We do that by doing opposite operations, by using opposite operations, and the final goal that we just have to keep in mind is whatever we do to one side, we do to the other. All of these rules that we learned about solving, the very general rules about solving, still apply to what we're doing here. So we're going to isolate the variable by doing opposite operations. So x divided by 4 is less than 5. What are the possible values that x can be? To do that, to give ourselves kind of we can guess and check this, right? I know the answer is going to be 20 because 20 divided by 4 is 5. But we want to learn a process. The process is important. So the process that we can follow to solve that is, since this is division, we do the opposite operation, multiplication, because we're undoing it. So 4 times x over 4, the 4's cancel out, leaving just the x. So x is less than 20. And we can graph that. And we have 20 here, and 21, and 19. So we have an open circle at 20, and then x is everything smaller. And what that says is, whatever values, any value smaller than 20, if we were to plug it in up here, it would create a true statement, right? If I were to plug in 10 in for x, that's a true statement. If I plugged in 19 in for x, that's a true statement. But if I were to pick anything on the right-hand side, anything larger, like 21 is less than 20, that is a false statement. That is wrong. And so this graph is representing all of the values that are creating true statements. Okay? Let's do another example of multiplication. Something funny happens on this one. So let's solve the problem like we did the last time, but then let's look at this funny thing that happens. So again, x divided by negative 6 equals 7. I know the answer to that question is negative 42. But just to show you the process, because we're dividing by negative 6, we multiply both sides by negative 6. These cancel, leaving x is less than negative 42. Now, let's check that answer. What this says is that any number that's smaller than negative 42, I should be able to plug in to my original equation and get a true statement. So let's just, numbers that work, let's do a quick graph. Negative 42, negative 43, negative 41. This is saying everything's smaller. So technically speaking, if I plug in negative 44, I should get a true statement when I plug this in back above. So actually, I'm going to choose negative 54 because that'll divide easier. Negative 54 divided by negative 6 is less than 7. Well, 54 divided by 6 is 8. Is that a true statement? No. Why did that happen? What's this funny thing that happened? And here's the thing that's different. This is why solving an inequality is different than solving an equation. It's the one tiny little change, right? One tiny little change. When we multiplied by a negative, we flipped the sign over here, right? Multiplying flipped the sign. And so this was no longer a positive over here, it was a negative. And what that means is, when that happens, when we multiply by a negative and this sign gets flipped, we also need to flip the inequality. Anytime you multiply by a negative in an inequality, we have to flip the inequality to the other side. Because as it turns out, the values to the left are not the correct answer on these ones. It's actually the values to the right that create a correct answer. Okay? And to make sure we get that correct answer on there, we need to remember that when, and I'm going to write this in like, let's do it in like purple and we'll write it large. When multiplying or dividing by a negative in an inequality, we must remember to flip, the inequality sign. And I'm going to do that big. Big purple, let's put a box in it because it's important. When multiplying and dividing by a negative in an inequality, we must remember to flip the inequality sign. So let's do this one correctly now. Lots of things to erase. Okay. So we're going to do the same thing. We're still going to multiply by negative 6. But when we do that, the negative 6 cancels, and we flip the sign. We went from a less than sign to a greater than sign, and then this became negative 42. So that our solution appropriately highlights the fact that it's the larger numbers that create true statements, right? Like, for example, if I were to plug in negative 36 into the original statement, we would get that. This is positive 6 is less than 7. Whoa, good. That checks out now, right? Because when multiplying or dividing by an inequality, we must remember to flip the inequality sign, okay? And just as a really quick, because I messed this up and I don't want to redo it, when we plug things in over here, we should be plugging them into the original statement. 10 divided by 4 over 5 is the right thing to do. I messed that up. I don't know why I did that, but I'm trying to fix it now. Anyway, I'm going to go back to this. When multiplying or dividing by a negative in an inequality, we must remember to flip the inequality sign. It's very important. I got some problems for you to do on your own back on your Canvas lesson. We will answer them in the next video. Go do that now.